So remember, in previous sections, we had been solving equations that involved only one step. Right here in this section, we're going to be working with problems that involve more than one step. So section 3.4 is going to be solving equations with multiple steps. Okay, so let's see. Remember, the goal is always to get the variable by itself on one side of the equal sign. Okay, so remember for a one-step equation, one step meaning it only takes one step to get the variable by itself. For example, if I had x plus 5 equals 7, how do I get x by itself? Well, all I have to do is subtract 5 from both sides, right? Minus 5. Whoops, this is an example, right? And I get x equals 2. Or another example of a one-step equation was 2x equals 16. Well, how do I get x by itself in this case? I simply divide both sides by 2, and I get x equals 8, right? So both of these are examples of one-step equations. Okay, so now an example of a multiple step equation. If I say solve 2x minus 3 equals 15, this involves multiple steps. And the first thing we need to do is to isolate the term with the variable first. So first thing to do is to isolate the term containing, whoops, I think I spelled that wrong, didn't I? Containing the variable. And remember what our terms are. It's a product of constants and variables, right? So if I say this is the term that I want to isolate that first, right? So we just pretend that that's what we need to get it by itself on one side of the equal sign. So what would I do? I have 2x minus 3 equals 15. Well, if I need to get this by itself, I'm just going to add 3 to both sides, right? Once I add 3 to both sides, I get what? These go away, so I simply get 2x equals 15 plus 3 is 18. Now this looks just like a one-step equation that I had, right? How do I get x by itself now? I'm multiplying it by 2, so I simply divide by 2, and I get x equals 9. Okay, so this required more than one step, but remember, the goal is always still to get the variable by itself in the end. All right, so let's try another one. What if I said solve 4x plus 5 equals negative 2x minus 13. Well, gosh, I have x's on both sides of my equal sign. So what I need to do is decide. Okay, so let's take a look at another example that involves more than one step. If I say solve 4x plus 5 equals negative 2x minus 13. So now I see I have terms that contain x on both sides of the equal sign. So I'm going to need to decide where I want to gather all of my x's. And I'm going to say let's move all the terms that have x's on the left. Okay, so remember I have two terms here, right? I have a 4x and a 5, and then I have a negative 2x and a minus 13, right? So what I want to do now, let's erase that. I'm going to get rid of my 2x on the right hand side by adding 2x. Right, so if I do that on both sides, my 2x's cancel. And I have a 4x plus a 2x gives me a 6x plus 5 still. Right, equals, since my negative 2x's are gone, I just have a minus 13. So now this is starting to look a little bit more like these problems that we're familiar with again. I'm going to try to isolate the one term now that has my variable in it. So I want to get rid of the 5 on the left. So that goes away. So I'm left with 6x on the left-hand side. And I have negative 13 minus 5 gives me a negative 18. And remember, the last thing I'm always going to do is to divide by the coefficient of my variable. So I divide both sides by 6. And that gives me a negative 3. Right? And I can always check it. So does 4 times negative 3 plus 5, does that equal negative 2 times negative 3 minus 13? So that's negative 12 plus 5. Does that equal 6 minus 13? And sure enough, I have a negative 7 equals negative 7. So I came up with the right answer. But if you notice, I had to do this in multiple steps. I had to take the first step I had to do was to gather all my terms that had my variable in it. On the left, I moved everything else to the right, and the last thing I did was divide. So this is what we talk about when we refer to multi-step equations, solving multi-step equations.